Right, let's see if it's any better then. Right, so apologies to you guys. Alright, take two. Take two. Take two. Okay, how's it going, Matt? Right, I need you guys to tell me what the stream looks like, because I have been having mad internet issues just now. I think I figured out why. I think I was overloading my USB bus on my computer, because I had all my webcams and my tethering, my phone plugged into the same USB chip on the motherboard, so I've swapped them around a bit, so hopefully this is now a lot better. I broke my internet. Yes, I broke my internet, and it's very complicated because I'm tethering, but I'm tethering using a separate third-party app that's bypassing my 3 tethering limit, and it's all a bit complicated. And I've got to make sure that my phone is on 4G, so when the internet was dropping out earlier, there was a whole number of things that could have been the cause. So I think I've fixed it now. I think I've fixed it. So far, way better. Thank you very much. Okay, so unfortunately, because of the way I want to do this video, the way that I had in my head and had planned for this video, I'm going to have to start the atomic repair video all over again from the start. So for those of you who are with me a few minutes ago, massive apologies. You're going to have to, if you already saw the atomic video up to like 24 minutes in, then just maybe go and make a cup of tea, go and do something else for 20 minutes and come back in a bit, but I'm gonna have to start it from the beginning because that's how I want it to be uploaded, and I'm gonna crop this start out of the video so it starts just at the atomic video, and then I'm gonna carry on with the repair on live a little bit later. So yeah, apologies for that. Also, another thing I just wanted to ask you guys before I get started: what is the lip sync, the audio and the video sync like? Is it synchronized well, or is my video ahead of my audio? Am I talking in sync or not? What does it look like? Because if it's not in sync, then I will change some settings. AV sync is good. That's really strange. Because when I watch these videos back, the AV sync is way off. But I'm glad that it's fine for you guys there. Okay. So we're going to start the atomic video again. Sorry, apologies for those of you who watched it a minute ago. We got about 10-15 minutes in, so I'm going to have to start it again. But for those of you who have just joined us, then we are about to start an atomic 7K. So this is a 7,000 watt amplifier from back in the day. Really nice board, really nice amplifier, quite old fashioned now. So basically I started this repair before I started live streaming these videos. So I've already recorded like the majority of this repair video, but I haven't finished the repair yet. So what I wanted to do was to play you the first 40 minutes of the repair, which is all cut so that you haven't got the long bits of me soldering in between. It's just a nice, like, to the point 40-minute repair of the atomic amplifier, and then I'll finish it off live for you guys after the video is finished. So if I get back to here, and let's get started with the first part of this video. This is a pretty big board we've got on the bench. This is a Atomic 7K. It's a pretty old amplifier, but it's one of the golden amplifiers. It's absolutely fantastic. Look at the size of this thing. So this isn't too dissimilar from the size of the Ground Zero 10K HC that I worked on before. You saw the video. We've got power supply is a little bit smaller, output section a little bit smaller, but in general it's the same basic circuit. Everything's laid out relatively nicely with a bit of good spacing, so the board has lots of thickness in the trace. The pads are nice and thick as well. We've got a good number of power supply capacitors and a good number of rail capacitors. Yeah, it's overall just a really nicely designed amplifier. The board design is very old, as with all of these amplifiers from Korea. It's not a new board, so this amplifier does 7,000 watts, which is less than this modern Brazilian amplifier does. But the Brazilian technology, I don't believe, is quite there with reliability yet. It's not there. So although this uses much older FETs, 24N40Fs or 20N50s, it's a much older design, but it's much more reliable because these have been tweaked and perfected for years and years and years and years. So yeah, this should be more reliable. And well, saying that, we've got one in here for repair. We don't know why this one went down, but we have all the output FETs already removed by the owner, who was looking to see whether we could do a repair on this. But I decided to bring it in as it might be a little bit easier. We can change the drivers if we need to here with the hot air station. So first of all, we need to check that the power supply is okay, which I believe it is because the customer said that we've had that powered up before. But let's just double check anyway. So the easiest way to check the power supply is literally just to take your multimeter probes. Which way are we here? And put it on diode beep setting and put it on the power terminals. Have numbers on the multimeter here which change, which should rise. So we've got a minus number there, let's flip that over. So if your multimeter numbers rise here, which means we're charging the power supply capacitors, and that is a good thing. So that means we're charging all these capacitors here. So if the power supply was dead, usually we have a short across the pins 2 and 3 of these FETs on the output section, which means that we would have a direct short circuit across the power terminals, which we don't. So the power supply is probably okay. So now let's have a look at the output section over here. So just before we power it up, I want to make sure that there's no short circuits on the main rails. So we just go along all the pads here, and there is. We've got a 26 ohm resistance on one of the rails here, and it's possible that that is as a result of solder bridges. So when these FETs are removed, we can see there's a little bit of solder that remains on some of these pads. So before we go any further, we're just going to go across every single pad of the output section to make sure that there's no solder bridges, because if there is, then that could cause a problem. We could then blow the power supply, or we could blow a regulation circuit. So that's what we're going to do first. Right, so gone through every pad, and it did look like there was a couple of solder bridges, so let's see whether that has disappeared, that resistance on there. Okay, no, we still have 25 ohms, and the 25 ohms is between the output and the ground of the output FET, so it's not on the gate. If we measure on the gate, we have a continuously charging value on the multimeter, so which is a little bit less common. I think there's quite a few issues here. We're going to need to put the Right, so this still seems to be lagging. I've still obviously got some fucking issues with my internet. I don't understand what's going on here. This was all working fine before I decided to move my PC. Whenever I stop VLC, it seems to be fine. Whenever I stop playing VLC, it seems to work fine. So what's up with that? Driver board, and we're going to need to test all these values with the driver board out to see whether there is a capacitor or anything that's dead. Now, if we have a look on the board, do we see anything else that looks suspicious? Yeah, this is fucking ridiculous, man. This is fucking ridiculous. I'm dropping horrific frames. Maybe it's to do with VLC then. Jesus, okay, what is the solution here? What is the solution here? Maybe I'll just have to upload this video completely separately and just do the live repair for you guys now on the last bit of it. Maybe I can change the, maybe it's Maybe it's using my GPU too much in addition to OBS. That's some bullshit. That is some bullshit. Right. Use hardware acceleration. Let's try turning hardware acceleration off, perhaps. Outputs. OpenGL, no. Input codecs, etc. Right, let's close the VLC and try it again. Open with VLC. With VLC media player. Come on, work for me, baby. Stick to itself rather than to the edges, and it will come up into the solder cycle nice and easy. So we're going to go along each of these. This is quite a big driver board. I think it uses 4 of the IRS T1844S drivers. Now, so whenever I enable VLC, whenever I turn VLC on, the fucking thing drops like crazy. Whenever I enable VLC, the thing drops like fucking crazy. Right, speed test. What's speed test saying? What is speed test saying? Windows Media Player I don't think gets picked up by OBS. Holy moly! What? You fucking kidding me? I reckon 3 are capping my speeds, you know? I think they've caught on to what I'm doing here. Fuck. Yeah, this is pretty bad, guys. I was getting 40 megs a while ago when I was actually doing this properly. Well, no, when I was doing this a few days ago. Ah, Jesus Christ. Okay. What can we do? What can we do? I'm really trying to rack my brains now as to think what the hell we can do. Reset the VPN. I'm not using a VPN. I'm not using a VPN. Alright, I'm going to try Windows Media Player. Let's see what happens if we open it in Windows Media Player instead. Open with Windows Media Player. Okay, yo, so and let's try to get OBS to capture Windows Media Player, and let's see whether that works. I don't think it captures Windows Media Player because this is all I get of the rails here, and it's possible that no, it doesn't capture Windows Media Player. That's why I was using VLC, because it captures VLC, but doesn't capture bloody Media Player, does it? Oh man. Hi Carlos, can you fix my internet? Can you fix my internet? Oh, Jesus. I don't get why my speed is so bad though. It's been fine, hasn't it? It's been absolutely fine for ages. I reckon I am being capped. Where's the lamp switch? What lamp switch? This could be the first time ever VLC is bested by Windows Media Player. Nah, man. I do like Windows Media Player as well, but I did this before though. Right, this is what I don't understand. I've done this before where I've streamed a video like this using VLC and it was absolutely fine. I had no issues whatsoever. So I don't know what has changed. What are we doing differently here? So I'm going to just check my dropped frames. My dropped frames are currently at 2,853. My CPU is at 23%. Okay, let's see what the cause is of this. I'm going to open it back up in VLC. Open it back
okay,
up in VLC.
yo, so this is a pretty big board we've got on the bench. This is a 7K. It's a pretty old amplifier, but it's one of the golden amplifiers. It's absolutely fantastic.
Video capture device.
So this isn't too dissimilar from the size of the Ground
Window
Zero 10K
capture.
you see that I worked on before. You saw the video. We've got the power supply is a little bit smaller, upper section a little bit smaller, but in general it's the same basic circuit. Everything's laid out relatively nicely with a really good spacing. So the board has lots of thickness in the trace. The pads are nice and thick as well. We've got a good number of power supply capacitors, a good number of rail capacitors. Yeah, it's overall just a really nicely designed amplifier. The board design is very old, as with all of these amplifiers from Korea. It's not a new board.
No, doesn't like it. Doesn't like it. I can't figure out why either. Don't think it's my RAM. Don't think it's my RAM. Oh, for fuck's sake. Peace out, Matt. This stream is an absolute failure. Okay, so guys, unfortunately I think what I'm going to have to do then is I'm going to have to upload that video just onto my channel, and then I'm going to have to do the live stream of the rest of the repair separately, which is annoying because I wanted to try and get it all in one video. So maybe in the meantime, maybe we'll look at this amp I've got on the bench at the moment, this Rockford Fosgate. Should we do that? The stream looks alright just for the time being, doesn't it? How does the stream look now? How are we looking now? Still looking bad. What the fuck? Yeah, it's still not quick enough for what I like. I'm gonna have to play with this to get it working. It was working perfect for the last few live streams, wasn't it? Was working perfect. Okay, so we're gonna do I'm gonna upload the atomic video separately, and I'm gonna live stream the rest of the atomic repair this evening a bit later on. But let's just see whether my internet is happy enough to do the. That's not a nice angle of my face. Let's see whether this live stream will continue working, and just as a live stream test I'm gonna be working on this Rockford amplifier here. This is a Rockford Fosgate, and the model number is, it's a Prime R300-4. So this is a 4-channel, it's a Class AB. Some people wanted to see some more Class AB stuff, and the first thing which I noticed when I took this out of the case is we have power supply gone poof. I'm still dropping frames. What the flipping hell is going on? I'm still dropping frames. Alright, we're going to carry on with this even though it looks like shit to a lot of you guys. I'm really sorry, I don't know what's going on. After this repair, I'm going to have to look at my settings, look at my 3 data and find out why this is not working now. The last few days have been absolutely fine, no issues at all, but now it's just dropping frames left, right, center, and my internet speed is like halved. Really strange. Really, really strange. So this power supply is, I haven't even really started looking at this yet. This power supply is obviously fucked. So we're just going to first of all clean up all this black and crap on the board. We had terrible snow here in the UK today. Pretty bad snow. I wonder if that's got anything to do with it. Although I wouldn't have thought that would have anything to do with mobile phone data. Or perhaps everybody's at home and perhaps everyone's watching Netflix and that's why my internet is so slow. Because the telephone mast is being overloaded. Who knows? All I know is no good for me because I can't live stream. Although if it was just my data connection, that would make sense as to why opening VLC ruins it. Why would that be a thing? Why would opening VLC ruin it if it was just my internet connection speed that was causing the issue? My PC is not overloaded either. We've only got about 60% usage on my CPU, so that's not it. So I'm just removing the little legs of these power supply transistors, which obviously went poof. This is a very nasty black and looking board. Even after I've cleaned it, it's still quite black. You can see the way where it's burnt the PCB quite badly. So we need to check that that's not conductive, because sometimes the PCB itself can become conductive between the pads and then we have to cut the PCB away. Is anyone else here from the UK? Did you get the snow bad? How badly did you get the snow today? Do you also repair Class BD amplifiers? Yeah, I'll give it a go. Class BD? Interesting. I'm not sure if I'm familiar with the repair procedure on those. It sounds like it's just a marketing gimmick to try and make a brand's amplifier stand out from another one, but let me know what's the deal with Class BD. What makes it different to others? I haven't looked that up yet. VLC will get greedy with your RAM. Yeah, I've done it before though. I've done this before. Do you remember before I actually started live streaming from the workshop? I was live streaming from the bedroom or from the sitting room, depending on where I was, and I would play you my videos and answer live questions at the same time, and that worked absolutely fine with VLC playing, no problems, no drop frames. Stream looked good. So I don't know why it's not liking it now. I've got a Class T amplifier in the workshop. I've got a Class T, but not BD. That does sound suspiciously like a marketing gimmicky name for something. A bit like how the Tripath, the Phoenix Gold Tantrum amplifiers, the Tripath is pretty much Class D, but Rockford Fosgate T4001 BD, for example, very hard to repair. Most people in my country have failed. I'd like to see the amp guts for one of those and to find out what's different about it. The Rockford are very good with their board designs, so if they're going to have done something clever, then fair enough. Ah, damn, look at this. Damn, son, look at this. So, literally, this board is just like turned to crap. It's just like turning to dust when I scratch at it. This has got so hot. This has got so hot. I need to get rid of all this black carbonized crap on the board here, because that will probably be conductive. Let's see. Let's see if that's conductive. So we need to take our multimeter now and put it onto 2M. 2M being the most sensitive setting for the multimeter. And we need to put it on not any pads, but we need to put it on the board itself, on this part of the board, because we need to see whether there's any resistance on the actual board. I think we may have got lucky here and there's not a resistance on the board. But we do need to dig some of that crap away, because that's just gonna... I don't like that being there. Wow, look, that's no good at all. Let's try this other one over here. Chevys not Hondas. Yeah, we're kind of back. We're kind of back. I've obviously got some underlying issues somewhere with either my internet connection or my PC is not happy about something. Whenever I try and put VLC on, it drops frames like mad. And I've used VLC before with OBS, and it's been absolutely fine. And my internet connection speed seems to have massively dropped, so I wonder whether 3R have caught on to what I'm doing, and they're limiting my connection speed. Could be something like that, who knows. Very annoying, whatever it is. Jesus. Nasty. This is no fun, this one. To be perfectly honest, I think I would rather cut away this section of the board and just mount it manually, because this is fucking no good. Jesus. Right, well, it needs new gate resistors anyway, so we need to remove... So this gate resistor here is wobbly as hell because it's not being held in properly by the pad on the bottom. See, this is the pad... this is the pad for that gate resistor, and it's really wobbly, where the board is just like turned to dust due to the heat. And this one as well is pretty turned to dust. See how wobbly that is on there? So what I need to do then is remove both of those. Where's my tweezers? We just need to take these pads straight off the board here, because I don't think these are going back on anytime soon. Look at that. Ah. Oh, you can't see. Oh yeah, you can. Where are we working? We're working over here. We're working over here. So yeah, this pad, I've just pulled it straight off the board. No good. So we need to do the same to this one, because these pads are toast. Toast. Suck the solder from the pads of the other pads for these gate resistors, so gate resistors can come out to play. Come out to play, Mr. Gate Resistor. Your work here is done. You can rest in peace now. Try an eraser, huh? So that's one of our toasted gate resistors. That can go. I would be extremely surprised if the drivers survived all of this. If the drivers survived this, then fair enough. But I don't get the impression that they will have. So the drivers here are, you got the TL494 here, standard procedures. And you got the little driver transistors here, which will drive the outputs, the MOSFETs. So let's take our multimeter now and let's check the drivers to see if they're shorted. Put it on diode mode. Beep beep. Okay. So the drivers don't appear to be directly shorted themselves, but they may be leaking, so we need to make sure that there's a nice clean square wave on these. What's up from California to the third era? How's it going, buddy? Good to see you, mate. My stream is just my stream is not my friend today. It's not been working how I want it to at all. I should probably change the video title because we're not working on a bloody atomic anymore, are we? Let's go ahead and change my video title. Stream showing me Rockford for channel AB repair. Let's save those details. Your changes were saved. Thank you. So if you guys refresh the page now, the video title should have changed to a Rockford repair. Okay, so these gate resistors got toasted up, so we can't read the values on those anymore. So we're going to read the values of the gate resistors on the other side to see what they should be. We've got 100 ohm gate resistors on here. Nah, I'm going to swap those out for 47 ohms because we're going to. Yeah, fuck it. We're gonna swap these out for 47 ohms because 100 is a little bit high. 100 is a little bit high for the FETs that we want to drop in here. The FETs we want to drop in here are probably a little bit newer. $100 ohms is quite high for a gate resistor for the sorts of FETs that we want to use here. So we're going to drop this down to 47 ohms. And that should work great. I'm not even sure why I'm bothering to repair this amplifier. Actually, this isn't even one that this is one that I currently own. I bought it in a blown state, but I've got other things I really should be doing. I was only going to be repairing this whilst the atomic video was playing, so I could pass the time. But obviously that didn't work how I wanted it to at all. So here we are repairing something that probably I shouldn't really be repairing at this point. But oh well. If it makes good content, then we'll do it. Right. Okay. So these pads here, which got obliterated. Why is that all the way over? Jesus. Right, these pads here, which got obliterated, you can see here. So we've got no more pad on the bottom of the board at all, anywhere, and the PCB, it's kind of really toasty and not very nice at all. So we're just going to make sure that this isn't conductive again. So we're going to take our multimeter and we're going to put it onto the highest, most sensitive ohm setting, 2M, and we're going to check to see that there is no resistance between the actual board itself. No, there doesn't seem to be any resistance on the board itself. Okay, that's good. That means we haven't got to cut away parts of this PCB, which I've had to do in the past. It's not nice at all. Not nice at all. Not nice at all. So, 47 ohm gate resistors are going in this bad boy. Where's my 47s at? Where you at, boy? Where you at, boy? 47s, here we go. We only need 4 of these. How was the snow for other people in the UK? Did anybody get snowed in today? Yeah, in the UK we had a lot of snow, and like our country kind of sucks and is not prepared for snow. Like, we literally lose our shit and nothing works when it snows in the UK. No one goes to work. None of the public transport works really. People crash into like everything. Yeah, boy! Just tuned in. What Rockford 4 channel are you fucking up? I'm fucking up a Prime R300-4. And I shouldn't really be doing this. This should have been an atomic 7,000 watt RMS repair video, but I seem to have internet connection problems and VLC is fucking pissing me off. And I can't give you that video just now. So I'm going to have a play around and I'm going to do some private live streams so you guys can't see me fuck up with the internet. And I'll try and fix whatever the hell is going on preventing me from being able to stream what I want to stream. It says stream offline, I can't watch the video. Really? Again? Stream health... literally, the stream health is dropping in and out every flipping 2 seconds. Look at this. Right? Look at this. This is my little log of the stream health. Bad, good, no data. Good, bad, good, bad, good, bad. It seems that every... Our stream has been healthy since 6:30, so I don't know why you've got any issues there. But literally every time that I enable VLC, it says stream health bad, and it doesn't. Nothing works properly. So I'm just replacing these gate resistors from 100 ohms down to 47 ohms, because that is what will work better with this amplifier. Now this isn't a hugely powerful bass amplifier, so for this one we don't need like crazy high powered power supply MOSFETs in here, and we only need 4 of them. So I own this amplifier. This isn't a customer repair. I inherited this in its blown state. So what we're going to do is we're going to fit some power supply FETs from my donor drawer. So these are all sorts of old power supply FETs which aren't 3205s. They're like different ones, maybe not quite as good, or cheaper ones that I salvaged from amplifiers that are working. And so what I'm going to be doing is I'll load this amplifier up with some of my salvaged FETs here, because that will work beautifully. But before we do that, we need to make sure we have good-looking drive waves on the gates. Yes, good-looking drive waves on the gates, and for that I need to enable my scope. I need to enable my scope, which is here. Da, 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 da. Scope is in view, y'all. What's up, Mr. Scope? What's up, boy? So let's apply some power then to this. I need to plug this into my small power supply, and of course it's missing some of the screws on here. Okay, let's get our power supply here hooked up. Yeah, this power supply was fucked. And before I turn it on, I'm actually just going to check that none of the output transistors have failed. That might be why this thing went down in the flipping first place. Skitty bop bop. Thanks for the update. I'm the one writing about the Rockford the other day. Oh, wicked. What's your opinions on Fairchild transistors? Yeah, Fairchild are fine. Should I have used FETs from Infineon rather than Fairchild? You wouldn't. I wouldn't have thought you'd notice a difference personally. They're both fine. I've used both Fairchild and Infineon with no problems before. I also use On Semiconductor quite a lot. Okay. Power supply is plugged in. Okay. Get my scope probe. Get my ground probe. Scope probe and ground probe, and let's put my scope in view. What happened there? Okay, so 9.6 volts. 9.6 volts up in here. How old were you when you started repairing amplifiers? It was 1 year ago, roughly a year ago, so I was 25. Or, yeah, 25, yeah. I'm actually going to have the amplifier this way up. Ah, man. The reason I'm going to have the amplifier this way up for the time being is because I need to save those the legs on those gate resistors, because I need those long legs to connect to the FETs, because we've lost the pads now. I will bench test this amplifier. Yes, I will bench test this amplifier. I clearly have a background in electronics. No, sir, I do not. I do not have a background in electronics. I have a background in car audio. So, distributing and selling car audio, subwoofer recones, audio electronics to an extent, but I've never done any classes in electronics. I never went to college to do electronics. I never took any, I've never done any electronics courses or anything like that. I literally, a year ago, thought, shit, I need to repair amplifiers because I distribute a brand that nobody will repair, so this is going to be a problem for me. So I sat down, I bought some blown amplifiers off of eBay or off of the community, bought some blown amplifiers for like 10, 20, 30 pounds each. I bought Perry's amplifier repair guide from Basic Car Audio Electronics 1 website. I spoke to a couple of people who do amplifier repair, and I gave it a go. I sat there and I worked out why it wasn't working. I probed things, and I tested things, and I bought an oscilloscope, and I did all this shit. And eventually I started to get it, and yeah, and here we are. So let's apply power to this board, and let's see what's going on. Okay. So I apply the remote and nothing changed. Oh, that's because my fucking power wire keeps coming out of this thing. Get back in there. Let's try it again. So we're applying some remote to this amplifier, and nothing's happening yet. No waves on the drivers here. Absolutely no waves on the drivers here. So the TL494 probably isn't working. So I wonder if this fuse is blown. Is this fuse blown? No, we have 9 volts either side of that fuse, so the fuse isn't blown. Elliot says, is this one I gave to you? Yes, it is. It is, my friend. This is the one that you gave to me. The power supply is absolutely fucked. Poof! Dead. So let's see what's going on with this TL494 then. So the TL4, so for this thing to come on, the TL494, which is just here, needs to receive 12 volts at VCC pin 12. So let's see if it's getting that first of all. 9, 10, 11, 12. Okay, so it's not getting VCC. See that on the scope there? So this is what's happening when I it came up there. Ooh, now we've got VCC. Okay, so now we have VCC after pulsing this for a little bit. So we've got 9 volts worth of VCC on the TL494. So if we check pin 5 now on the 494, pin 5 should be a nice big sawtooth wave. That's quite a small sawtooth wave. Yeesh! That doesn't look good. That's not what it should look like at all. Wow. Okay. That's not the sort of sawtooth wave that we're used to seeing on the 494. Not at all. Okay. Another thing we can do to see whether the 494 is working properly or not is we should have a nice, accurate 5 volt regulator on pin number 9, 10, 11, 12, 13. Okay, so we do have a nice 5 volt regulator on pin 13. Okay, so what else have we got on here? So pins 1, 2, 15 and 16 are inputs to error amplifiers. So pins 1 and 16 need to be lower than pins 2 and 15 for this thing to turn on. So pin 1 is 2 volts, pin 2 is 4 volts, that's fine. Pin 15 is 1 volt and pin 16 is 1 volt. So they're about the same there. See here, pin 16 is lower than pin 15. So that's probably why this thing isn't turning on. If we check pin 3 is the output of those error amplifiers. But pin 3 isn't high. Pin 3 is not high. So the error amplifiers are not saying that there's an error anywhere because pin 3 is low. So if the error amplifiers were switching on to say that there was a problem, pin 3 would be high, which it's not, it's low. So pin 4 is quite high, it's at 2.4 volts. Pin 4 is the dead time control of the TL494. So the voltage on pin 4 here will decide how much pulse width modulation percentage is on 9 and 10. And it looks like here, if we actually zoom into pins 9 and 10, we have something that's trying to resemble a square wave but failing. See that? So it's trying to generate a square wave but it's failing. It probably has something to do with the crappy sawtooth wave we have on pin 5. So let's see whether anything on the board is heating up here. Okay, let's put our thermal imaging camera on here and let's see. Is anything getting hot that should not be getting hot? So the TL494 is not getting hot. None of the driver transistors are getting hot. Yeah, nothing around here is getting hot. So, you know, there's no short circuits or anything where there's any current involved that would be causing that. Josh says, I've got a pen and pad. What should each pin be? Let's go for Josh, just for Josh, let's go through what each pin should be on the TL494. I can send you a nice diagram picture as well of what each of them should be. So, can we zoom in here to the 494 a little bit more? Okay. So, Josh Hansen, are you paying attention, buddy? So, the 494 looks like this. Pin number 1 is always underneath the notch. So you've got the writing is this way round. Pin 1 is always the bottom left-hand side. So, pins 1, 2, 15 and 16 in a 4 square like this. These are inputs. And the inputs here are used to compare different voltages, which obviously the board designer can send whatever voltages they want to 1 to 15 and 16. And what the chip will do is it will compare these voltages, and then depending on what those voltages are, the output of these inputs, so these are 4 inputs that go into error amplifiers. Error amplifiers are they're OP amplifiers, and so they listen to 2 voltages, and then depending on the voltages on these inputs, the output of the error amplifier will change. So the output of the error amplifier for both 1, 2, 15 and 16 is on pin 3. So if the voltage on 2 and 15 is lower, so if 2 and 15 is lower than 1 and 16, so if the voltage on 1 and 16 is higher than these two, then the output at pin 3, the output of the error amplifier will be high. So if you probe pin 3, you'll see like 5 volts on there. However, if the voltages on pins 1 and 16 are lower than the ones on 2 and 15, then the output on pin 3 will be low. So that's what we've got here. If you can see, when I probe pin 3, it's nothing. We've got low. So if we probe number 1, we can see that we've got 2.4 volts, but number 2 is 4.3 volts. So that's correct. 1 is lower than 2 for this error amplifier, so that's fine. If we go ahead and we probe these two over here, 15 is 1.7 and 16 is 1.6. They are almost exactly the same. There is a degree of tolerance here, where if they're close enough, then the error amplifier won't switch on. So because these are close enough in voltage, 1.6 and 1.7, the output of the error amplifier here is still 0. So that's why we get nothing on pin 3. So that clears up 1, 2, 15, 16 and 3. Pin 4 here, pin 4 is used to control the dead time on the outputs. So this chip needs to output some square waves to drive our power supply. And the pulse width of those square waves is determined by what is on pin number 4. So if pin number 4 is high, if we have a higher voltage on pin number 4, then the pulse width modulation will be so small that there will be no output. As you start to lower the voltage on pin 4, as pin 4 voltage starts to come down slowly, the pulse width on the outputs of this chip starts to widen, so you start to see a square wave. You'll start off with a very small bump, like a tiny square, and then a lot of dead time, a lot of 0 volts, and then the lower that pin 4 goes, the wider the square wave becomes until you get to 50% pulse width modulation. So pin 4 needs to be low-ish for this thing to actually work. We're currently sitting at 1.5 volts. I don't think this chip's working properly at the moment, so we're not sure what to guess on here. So that clears up pin 4. Pin 4 is setting the pulse width modulation on the outputs. Pin 5 should be a nice sawtooth wave, and this is the frequency which this chip is operating on. You see there, we've got a nice sawtooth wave on there. Well, it's not a nice sawtooth wave. This one is a crappy looking sawtooth wave. So that's something we need to look at. When this chip is healthy, we have a nice sharp looking sawtooth wave, but that doesn't look good at all. On pin number 6 and let me get this right. There's one that I forget here. I think it's pin 6 and 7 are to do with setting the frequency of this sawtooth wave. So you see the sawtooth wave here? No. Pin 6 and 7 you have a 3 volts, 3.3 volts on here, and on pin 7 you have nothing. And there's a capacitor and a resistor that are connected to pins 6 and 7, and the values of the capacitor and resistor together will determine the frequency of the sawtooth wave on pin 5. I can't remember off the top of my head what pin 8 is just now. But we've got 9 volts on it, so I'm assuming it's some kind of VCC, some kind of VCC input. Now pins 9 and 10 are the outputs of this chip. So on pins 9 and 10 we should have a nice looking square wave, which we don't. So we need to find out why that is. So on pins 9 and 10 there are out of phase square waves. Pin 9 will be 0 degrees and pin 10 will be 180 degrees. So they'll be out of phase with each other, and that is the output waves that drive the FETs. Pin number 11 is pin number 11. I can't remember what it is exactly right this second, but it's not that important. Pin 12 is VCC in. So pin 12 is where this chip gets its power. So it's getting 9 volts in here from the power supply, and that's what it needs to operate. Pin 13 is the regulated 5 volts. So this chip has a very accurate 5 volt regulator built in, which is on pin 13. So if the chip is working well, you should see 5 volts exactly on pin 13. Pin 14, I found out what pin 14 was the other day. I don't think it's that important. Oh, sorry, no, oh shit, I think it's pin 14 is the 5 volt regulator. But pin 13 sets the operation mode for this chip. So this chip has 2 operation modes. It either has push-pull configuration or it has single-ended operation. And for all car audio amplifiers, it's going to be needing to work in push-pull configuration. So pin 13, if pin 13 is high, it'll work in push-pull. If pin 13 is low, it'll work in single-ended. So pin 13 needs to be high, and pin 13 is usually connected to pin 14 on the board, so they both should be at 5 volts for this thing to be working properly. So that pretty much covers all of those. What I'll do is I might post up a nice picture that shows all of the outputs and all the pins on the TL494, so you guys can see what it is. Okay, so we're gonna pick up back with this amplifier a little bit later. I am gonna go and have some food now. I'm gonna have some dinner because we hungry up in here. We hungry. So yeah, I'm going to go get some food, and I'm also going to troubleshoot what the fuck's going on with my internet connection so I can try and stream you this Atomic video. So thank you for tuning in to this random mismatch of crap. This live stream has been an absolute failure, so apologies. I will speak to you guys in a little bit later this evening, so stay tuned, watch your emails, watch your notifications on YouTube, because I'll be live a little bit later on, hopefully with some interesting repair stuff that I tried to do for you guys earlier. See you in a bit.